Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to write an inequality from a real-world situation. Now, before we do that, we need to review some common phrases and the inequality symbol that's associated with them. So our first two common phrases that we need to determine a symbol for are this phrases is less than or fewer than. And the symbol we use for those phrases would be the less than symbol. Okay. Our next two phrases is greater than or more than. And that would be the greater than symbol. All right, our next phrases is less than or equal to, at most, no more than, or a maximum of. And all of those phrases could be represented with the symbol less than or equal to. Our next set of phrases is greater than or equal to, at least, no less than, or a minimum of. And we can use this symbol to represent those phrases, greater than or equal to. In example 1, it said use a variable and an inequality symbol to represent each of the following. So in problem A, it says Andrew has fewer than 3 pets. So I'm going to go up here and highlight fewer than. The symbol we use for fewer than is the less than symbol. So I'm going to use P to represent Andrew's number of pets, and he has fewer than 3 pets. So P, number of pets, is less than 3. So he could have 2 pets, 1 pet, or 0 pets. Okay. Problem B, Macy grew at least 2 inches last year. Now, think about Macy's growth. If she grew at least 2 inches, that means she could grow 2 inches, 3 inches, 4 inches, 5 inches, 6 inches. So her number of inches must be greater than or equal to 2. And that phrase was right up here, at least, greater than or equal to. All right. Problem C. Jaden can fit no more than 6 people in her car. No more than 6 people in her car. So she could fit 1 person in her car, 2, 3, 4, 5, or 6. So all the people have to be a number smaller than 6. So I'm going to say the people must be less than or equal to 6. D. Miss Garcia plans to spend no less than $1,000 on her vacation. Now, this one is confusing here because of this word no in front of the less than. No less than. So ask yourself, could she spend $900 on her vacation? No. It says no less than. So that means she's going to spend $1,000 or more. So I'm going to put her spending, S, must be greater than or equal to $1,000. She's going to spend more than $1,000, okay? E, Cassie's suitcase can weigh a maximum of 50 pounds. So that means the suitcase could weigh 50 pounds, 49, 48, 47, but all the weights have to be less than or equal to 50 pounds. Okay? Now, pause the video and try problem F on your own. All right, welcome back. All right. Now, it doesn't matter what variable you used for this problem. I used W to represent the water, and it says Sydney drank a minimum of 16 ounces. That means she drank 16 ounces or more. So I used greater than or equal to 16. So fix anything that you got wrong on that particular problem. All right, example 2. Rugs Emporium installs carpet for $80 plus $9.50 per square yard of carpet. Carpets for You charges $120 for installation and $7.50 per square yard of carpet. Write an inequality to find the number of square yards of carpet for which Rugs Emporium charges less than Carpets for You. So in problem A, they want you to define the variable. So let's find what is our unknown here. What are we trying to find? And we're trying to find the number of square yards. So that's our unknown. So I'm going to let x, and it doesn't matter what variable you use, equal the number of yards of carpet. Okay. In part B, they want us to write an expression for Rugs Emporium. So Rugs Emporium installs carpet for $80 plus $9.50 per square yard. So that would be 80 plus 9.5x. All right, C, write an expression for Carpets for You. So Carpets for You charges $120 plus $7.50 per square yard. All right, now write the inequality. Now to write the inequality, we need to find our clue word. So let me grab a pink highlighter. It said, write an inequality to find the number of square yards of carpet for which Rugs Emporium charges less than Carpets for You. So we want the Rugs Emporium equation, which is 80 plus 9.5x, to be less than the Carpets for You, which is 120 plus 7.5x. And on this particular problem, they don't want us to solve that inequality. They just wanted you to write it. Okay. Example 3. The school band is selling pizzas at their concession stand for $7 each to raise money for new uniforms. The supplier that they buy the pizzas from charges $100 plus $5 per pizza. Write an inequality to determine how many pizzas the band must sell to make a profit. So in problem A, they want you to define the variable. To define the variable, we need to know what is unknown here. And look at your last sentence. Write an equality to determine how many pizzas. So we don't know the number of pizzas. That's our unknown. So I'm going to let P equal the number of pizzas. Again, you could use X. It really doesn't matter what variable you use. Okay. Problem B, write an expression for the band. Well, all we know about the band is they're going to sell pizzas for $7 each. So the band would just be 7 times X, or 7 per pizza. Okay. C, write an expression for the supplier. Well, we know the supplier charges $100 plus $5 per pizza. So 100 plus 5x. In problem D, they want us to write an equality to determine how many pizzas the band must sell to make a profit. Now, in order to make a profit, the amount you sell must be greater than your costs. So in this problem, this 7x must be greater than the cost to buy those pizzas, 100 plus 5x. All right, now let's look at actually solving some of these inequalities. Look at example 4. Abby is trying to decide where to have her birthday party. If she has her party at an ice skating rink, it will cost $40 plus $18 per person. If she has her party at a trampoline park, it will cost $120 plus $8 per person. How many people would Abby need to have at her party for the cost of the ice skating rink to be less than the cost of the trampoline park? All right, so we're going to start off by defining our variable. So in this problem, we do not know the number of people. So that's your variable. So I'm going to let P equal number of people. You know what? I just realized that we made a mistake. It's not really a mistake, but let's go back to example 3. we said we were going to use p for our variables. So I'm going to rewrite each one of those equations with a p and just show you that it is the same exact answer. Okay. And really, I'm kind of glad that happened because I want you to see that it doesn't matter which variable you use. You'll still get the same answer in the long run. Okay. So back to example 4. All right, we're going to let P equal the number of people. All right, we want an expression for the ice skating rink. See, ice skating rink was going to charge $40 plus $18 per person, so plus 18p. The trampoline park, they're going to charge $120 plus $8 per person. All right, now we want an inequality. How many to determine the number of people she needs to have at her party for the cost of the ice skating. That would be the 40 plus 18p to be less than, so I would need to use a less than symbol, the cost of the trampoline park, which was 120 plus 8p. Now, in this problem, they actually want you to solve it, okay? So I'm going to come over here. I'm going to write this inequality one more time. 20 plus 8p. And I'll start on the right side. And I need to remove that 8p. So I'll subtract 8p from this side and subtract 8p from this side. So 40 plus 18p minus 8p is 10p, and that's less than 120, and this zeroed out. All right, now we can just solve it for p. So I'm going to subtract 40 from both sides. So 10p is less than 80. And then divide both sides by 10. So the number of people has to be fewer than or less than 8 people. Okay. So I'm going to say Abby must invite fewer than 8 people for the cost of the skating rink to be less than the cost of the trampoline park. All right, example 5. Consider the rectangle and triangle shown below. For what values of n will the rectangle have a perimeter that is greater than, let me highlight that, the perimeter of the triangle? So let's start with the perimeter of the rectangle. So we know in a rectangle, to find the perimeter, we have to add 4 sides. So I know that side is also n, and this side is also 0.8 n plus 0.2. So to get an expression for the rectangle, I'm going to come over here, and I'm going to add like terms. So I'm going to add 0.8 plus 1 plus 0.8 plus 1. So that is 3.6 n. Where's that? Get my pen. 3.6 n. Now I need to add my constants together. 0.2 plus 0.2. So that would be plus 0.4. Now, for the perimeter of the triangle, I'm going to add those 3 sides together. So let me highlight my like terms here. I have 1n plus 1n plus 1.2n. If it makes you feel more comfortable, you can put that in your calculator, or you can solve it in your head. So that would be 3.2n. And then I have my constant terms that I need to combine, 0.6 and 0.4. Well, that is just 1 if you add those together. So this would be plus 1. Now for my inequality, we want the perimeter of the rectangle, which was 3.6n plus 0.4, to be greater than the perimeter of the triangle. So 3.2n plus 1. All right, now they want you to solve that. So we're going to come over here. I'll write it one more time so we have a little bit of room. 3.2n plus 1. All right, when I'm working with inequalities, I always start on the right-hand side and remove the variable from the right-hand side. So that means I would be removing 3.2n. Okay, so minus 3.2n. All right, 3.6n minus 3.2n is 0.4n plus 0.4, and that is greater than, this zeroes out, 1. Okay, now I just have an equation to solve here. I will subtract the 0.4. So I get 0.4n is greater than 0.6, and then we just divide by 0.4. Now, if it makes you feel more comfortable, you can come over here and put that in your calculator. 0.6 divided by 0.4, and that gives us 1.5. So, to write our answer, when n is greater than 1.5, the perimeter of the rectangle, I'll just abbreviate that, will be greater than the perimeter of the triangle. And that concludes today's lesson on writing inequalities for real-world situations.